Okay, so let's go ahead and talk about this process of factoring. And like I said, we're going to learn many, many different techniques on how to factor certain problems. However, one rule is constant. So, rule, and this I'm putting in red because it is extremely important, and that is the following. Always attempt to find a GCF first. Anytime that the instructions ask you to factor something, automatically your mind should be thinking, okay, is there a GCF here? Once you've taken care of that GCF step, then you can move on. This is sort of like a preliminary rule before you even begin to solve certain factoring problems. Always. Now, will you always have a GCF? For example, can you find a number between 2 and 7? No. Other than 1, of course, but 1's irrelevant at this point. Okay? So, again, always try to find a GCF first, and that's what we're going to practice on right now. So, to factor a GCF, okay, 1, you need to find the GCF, of course. Okay, and 2, you need to divide every term by the GCF. Okay, and then you will have it factored. All right? So I guess the best way to really show you what's going on, guys, is to kind of jump into with examples here. So follow along. If you feel like you're getting lost or you feel like you're getting overwhelmed, just pause it, go back to the beginning, and just rewatch what you have before you, because you don't want to, snowball into a big mess in the end, and the next thing you know, you're completely lost. So, again, take your time when you're learning this material, all right? Okay, so let me move this off to the side for a moment and start doing some problems with you. Okay, now, notice how the instructions here say to factor. It doesn't say simply, oh, find the GCF and call it a day. We're actually going to apply this process now. So, you're going to look at your two terms here. Now, right off the bat, I start with this problem because I usually get this question a lot. Do you have to factor out a negative? The answer is no. You can simply just divide it out when you are doing your factoring, and I'm going to show you that in a moment. So I want you to ignore the negatives as if they're not there for right now. Okay, and I want you just to do the numbers for me. Okay, between a 100 and a 10, what is the greatest common factor, the number piece? Okay, now take a moment. If you need to use your calculator, use it. Okay, but the greatest common factor between a 100 and a 10, guys, is just a 10. All right? So that takes care of the number part. Now the variable part. Okay, you've got x, and this one has an xy. Now, again, I'm just going to do one letter at a time. Let's only look at the x's. Do they both have an x in common? The answer is yes, so I can take it out. Now, can I put a y out here as part of the GCF? Okay, and the answer to that is no. And why do you think that is? Okay, it is because does this first term have any kind of y attached to it? It does not. Okay, so because they don't have it in common, I cannot take it out. So 10x is the GCF. So you've done step number 1. Now step number 2, you're going to divide every term by the GCF. And to do that, you're going to open a set of parentheses like so. And we're going to take the negative 100x and divide it by the 10x. We're going to take the negative 10xy and divide it by the 10x. So let's do the first term. What's negative 100x divided by a 10x? Well, if you just look at the number part first, negative 100 divided by 10 leaves you with a negative 10. And what happens to this x and this x? Correct, it cancels out. Okay, next step, drop down the negative. What's 10 divided by 10? It's 1. X and x are going to cancel out. And you're only left with a y. So the answer to this is 10x times negative 10 minus 1y. Okay, so this is the final answer. Okay, now I always get all the time as a math teacher, hey, is this correct? Did I do this right? Okay, well, the nice thing about math is most of the time you can check yourself. And the nice thing about factoring, remember, it's a process, right? It's a process of us trying to go back to the question. Sort of like this is the answer. So if I took 10x here and distributed it out, will I get negative 100x? Will I get negative 10xy? Well, let's check it out and see. 10x times a negative 10 gives us a negative 100x. And 10x times a negative 1y gives you a negative 10xy. Do you see how the problem and my checking solution, how they both matched up? I know I've done it correctly then. Okay? Let's look at number 2. Okay? Same song and dance, guys. I'm going to try to find the GCF of just the numbers first. Okay, so take a moment, use your calculator, and see if you can figure out what is the GCF between an 8 and a 36. Okay? And in this case, it's going to be a 4. All right? Now, M's. How many M's can you take out here? Okay, hopefully you answered 1 M. Because this one has 1 M, this one here has 2 M's. And we want the greatest that they have in common. Okay, so in that case, they only have 1 in common. Okay? Can you take out an N anywhere? No, because there's no N attached to this term right here. Okay? So now you're ready to divide. Okay? So 8 divided by 4 gives you 2. M goes into M. Okay, so those are going to cancel out. And don't forget about the N to the 5th. Drop down the plus. 36 divided by 4 is a 9. And M to the 2nd divided by an M, remember our exponent rules now. When you divide, you subtract the exponents. So 2 minus 1 leaves you with just a 1M. Okay, and this is the factored form. Okay, let's do number 3. Okay, so we're thinking about 15 and 25. Okay, so what is the GCF of 15 and 25? We'll take a moment, use your calculator if you need to. Okay, it is 5. Now, at this step, I'm not sure yet or not, but you may have started picking up on something here. I'm going to sort of give you, and I say sort of because it really is sort of, a shortcut. And that is this. If you look at your terms and they both have an X or they both have some sort of Y in common, if you can find the lowest exponent of all those X's or all those Y's, that's what you're going to take out. So if I backtrack for a second to number 2, do you see how they both had an M? Okay, they both at least had 1 M, but what's the lowest exponent? Remember, there's a 1 here. Right, so that's why I took out the 1 M. Okay? So back here, if I look at my X's, okay, they both have X's in common. Okay, so what's the lowest exponent? 1, so just take out 1x. They both have Y's in common. So what's the lowest exponent you see there? Right, 1y. But remember, guys, and I keep saying this, and I'm sorry if this is getting a little irritating. However, it is the common factor. It's what they have in common. So please keep that in mind. Okay, let's start to divide. 15 divided by 5 gives you 3. X and X cancels. Y squared divided by Y leaves you with 1y. Drop down the plus. 25 divided by 5 is 5. X and X cancels. Y and Y cancels. You're done. Okay? Remember, you do not want to stop with the with just taking out the GCF. You want to make sure that you divide it out. Okay? All right, let's do a little bit of a more challenging problem right here. What if you had 3 terms here and I asked you to find the GCF? Okay? Remember, are you going to worry about that negative? No. We're going to pretend it's not even there. And doesn't this look familiar? Didn't we just do 63, 9, and 27? Okay, good. So in that case, the number was 9. Okay. Now let's look at our V's. I see 2 letters here, V and U. Let's do one at a time. V. I see 7, 6, and 3. What's the lowest exponent that you see? You should have picked 3. Okay. Can you take out a u? The answer is no, because does this term have a u? No. Does this last term have a u? No. So that's my GCF. And now we start dividing. Okay, so negative 63 divided by 9 gives you a negative 7. I know you all know your times tables. Okay, now v to the 7th divided by v to the 3rd leaves you with a v to the 4th. Remember, subtract the exponents. And don't forget about the little u. Make sure you drop that down. Plus sign. 9 divided by 9 is just a 1. v6 and v3 gives you v3. Remember, we're subtracting exponents. Drop down the plus sign, and 27 divided by 9 is 3. V3 and V3 cancel out. You are done. Okay? Don't worry, you're going to get some problems to try in a moment, but I want you to sink that in and really understand what we're doing here with this GCF business. Okay? Because remember, with any problem that says to factor, this is always going to be your first step. Find the GCF, do a division, and then from there you would see, okay, can you do anything more? Okay? So we're going to next look at what's called the differences of squares.